All right, let's go ahead and kick things off. So like I said, thanks for joining us today for our webinar. This is our vendor series, so I'm actually really excited for this topic. It is one that is really relevant, at least in some of the work that I've been doing in industry. So I am super excited to hear from both of our speakers today. Today we're going to be covering using data virtualization to enable self-service analytics with Prologis. So if you're just now joining, that is the event and topic we're going to be covering in today's session. We also have another session on Thursday, which I will talk about a little bit later. So just a quick overview of the agenda. I'm going to spend the first 5 minutes or so getting everybody oriented, an introduction of WIA and Denodo, our sponsor for this vendor series. And then we're going to jump right into the good stuff in about a couple of minutes. We will leave 15 minutes at the end for some Q&A. So if you want to orient yourself real quick, there is a Q&A button at the bottom. So as you start listening to the talk and thinking of questions that you want to ask our speakers, feel free to just throw them in there throughout the entire presentation. And then at the end, we'll go through those with the speakers. And then we'll conclude with about 5 minutes at the end. We are recording the session today, so we'll tell you how to access that after we conclude. So a little overview of the vendor series. It is a free virtual series featuring leading analytics product and solution companies. The series is delivered in a 2-part webinars that cover a use case, which we're going to cover today, and then a technical deep dive, which we'll cover on Thursday. So if you're interested in more information about the product that we're going to be talking about that's behind the concept we're discussing today, then feel free to go ahead and register for that event on Thursday. A little bit about women in analytics. So if you're new to the organization, our entire mission is to increase visibility of women making an impact in the analytics space. And so we do have a membership platform that we launched this year, which has a lot of really great resources. It has an event calendar, a resource center, a job board, and we're actually launching a new membership in the next week or so, which includes a lot more like learning groups, an archive of all of the events that we've done that you can get access to. So if you're interested, go to womeninanalytics.com and take a look at the platform that we have. A little bit about the sponsor. So Denodo is the sponsor for today's and Thursday's series. They are a leader in the data virtualization space, and we'll get to learn a little bit more about them and their product on Thursday, as well as some of those concepts around data virtualization today. Some webinar tips. So if you are having audio issues, use the chat or email us. If you have a question, like I said, go ahead and put that in the Q&A and we will get started. So our 2 speakers today, we have Katie Hyde and Jennifer Garcia. Katie is the Program Director of Data and Analytics at Prologis. She leads the data visualization vertical, as well as having the responsibility of the day-to-day operations of the larger data and analytics team, ensuring project success for their customers and vendor partners. Katie has over 20 years of experience in business intelligence and analytics through various roles, including business analyst, ETL developer, data modeler, and project manager. Additionally, she is a certified Scrum Master and product owner. Thank you, Katie, for being with us today. Secondly, we have Jennifer Garcia. She is a senior data science engineer on the data and analytics team at Prologis. She is responsible for advancing predictive analytic capabilities on the enterprise level in a cloud-first data virtualization environment by creating an architecture of applications, cloud environments, and data strategy. Thank you both for being here. I'm really excited for you to jump into this topic. And with that, I'm going to go ahead and give you the floor.
All right, thank you very much. So self-service analytic users, they want simple and intuitive. They want it fast, and they want to trust the data coming out of it. I'm going to give Jen just a second here to share the presentation. Uh-oh, we lost Jen. I'll just go ahead and start talking and she'll join in. So good morning, everybody. As Reagan mentioned, I'm Katie Hyde, the Program Director for the Data Analytics team, and Jennifer Garcia will be joining us back here in a second. She's our Senior Data Science Engineer. We'd really like to thank you for taking the time to join us today to talk about the evolution of self-service analytics at Prologis and how we are incorporating data science to allow our everyday business users to take advantage of the capability it provides, including making sure it's simple, intuitive, fast, and trustworthy. First, I want to tell you a little bit about Prologis. Prologis is the world leading REIT. It's a real estate investment trust. We were founded back in 1983, and we provide logistic real estate solutions and pride ourselves on our outstanding customer service and relationships. At Prologis, we own or operate 976 million square feet across 19 countries on 4 continents. Within those walls, our tenants employ over 850,000 people, and there's over $2.1 trillion of economic value flowing through each year. That represents over 2.5% of the world's gross domestic product. I'm sure with the recent Black Friday, Cyber Monday, and the holidays that we're in and upcoming, I'm sure that there are some packages that are probably sitting or coming to your house soon that have probably gone through a Prologis warehouse. And I'm just gonna stop right here. Actually, can you go back up one, Jen? Since we weren't able to see the diagram before while I was talking, you can see down here on the bottom, these are all of the various source systems and processes such as Lambda or Jupyter that we bring data in to Denodo, and then our meta layer and our top layer, which I'll talk about a little bit more. And then you'll see Snowflake up here on the top. And then coming out of Denodo, we have various tools and applications such as Tableau. So moving on, our data integrations team has developed a process to ingest Excel files through Box. Users initially bring their Excel file to our team, and we will set up a process using the AWS Param Store and Snowflake Snowpipe to ingest that data into Snowflake in JSON format. After that initial setup, this diagram takes you through the ingestion process. A file is uploaded into the Box directory that we've provided to the user. The process will confirm that there's a parameter in the AWS Param Store matching the file they've uploaded. And if so, it converts it to JSON, and then it places it into an S3 bucket. On the bottom portion of this diagram, you can see that Snowflake Snowpipe then takes that data from S3 and lands it into Snowflake in JSON. And then from here, we can curate that data into Denodo, and users can use that data by itself, or they can join it to any other data that they have access to in Denodo. When the users want an updated data set, they drop their file into Box, and within minutes, they have updated data. We all know those data sets that exist only in Excel that this process works perfect for. The other use case for this is to be able to create a prototype. The business users can give feedback on it, or it could even possibly be an interim solution while the longer term solution is built out. It has had fantastic response to the capability of it. One of the advantages of data virtualization is that the creation of these derived data sets is not happening just within our own data and analytics team. We have several capability teams within Prologis who use the same base data that we've brought in from source systems or through the data lake and create their own various data sets. With the ease and speed of creating these derived data sets, this provides the opportunity for these capability teams to create what we refer to as uncertified reporting. Uncertified reporting allows the users to do self-service and create their own analytics at their own speed. And then they can share this with a small group, typically their own business area. Uncertified reporting is created by the business users themselves, a capability team, or through one of our vendor partners who operate as an extension of our own team. When a data set has been established in Denodo, we have the opportunity to utilize and share this data through a Snowflake Sharehouse, OData through Denodo connecting to Excel, provide APIs, and to, of course, utilize this data within our own analytics tool, Tableau. Jennifer will be taking you through some of those examples later on. We've had several instances where a business user has created a dashboard using Excel as the data source, And then when they are ready to share that with others, they bring it to our team. Using that box ingestion process, we can establish their data as the data source in Denodo. And then our development team from one of our vendor partners takes their dashboard and repoints it to the data lake. So now it can be published on Tableau server and shared out. We do have controls in place over where and to who this data can be shared with unless it's certified. Certified reporting, like uncertified, can be created by any user or capability team who will then work with our team to take it through the certification process. Three major advantages of certifying is being able to share it with a wider audience and embedding into other applications such as Salesforce, enabling row-level security, and also performance improvements that we can receive from doing things like caching within Denodo. Certifying data can occur one of two ways. The first is taking the uncertified data set and working with our team to document, ensure it conforms to standards, and passes data governance controls to ensure the name of the metric doesn't align with another metric with a different definition, and of course that it's quality tested. The other way to ensure your data is certified is to use building blocks, which leads me into the first of three accelerators that we use to support self-service analytics. I'm going to take you through how we create and use building blocks, and then Jennifer is going to take over and talk you through our data science toolkit and pipeline deployment model. Building blocks are created by our data solutions team and are a derived data set coming from a variety of sources at a canonical level. These data sets are extremely well defined, documented, and quality tested. The use of these building blocks ensures consistency as they are highly reusable across various subject areas and provide for faster data analysis as the difficult task of defining the metrics and attributes and curating that data has already been accomplished for you. Utilizing Denodo's cache based on Snowflake, users are able to quickly analyze and explore this data utilizing their own tools or through Tableau. Moving on into this diagram here, this looks familiar from our current state architecture, but this focuses strictly on the building blocks. You can see on the bottom layer, we have brought in data from a variety of sources, and here we're going to retain its current structure. In the middle layer, this is where we're going to create the building blocks. This is where we're going to join the data together from the various sources. We're going to give them standard naming conventions. We're going to ensure that the metadata is embedded for use by others in Denodo or even our own data catalog tool, data.world. And then we're going to run quality tests consistently to make sure that there is trust within that data. And then from here, we're going to take it to the top layer. And this is where we join multiple building blocks together to create what we refer to as starter packs. Starter packs are created based on a subject and can be utilized within other systems, such as Sigma for data exploration, or within Tableau for self-service analytics. One building block, for example, unit or building, which are commonly used at Prologis, can be utilized across many starter packs, allowing for that reusability and, most importantly, consistency. Starter packs allow a Tableau user to essentially drag and drop to create their analytics based on these governed, predefined metrics and attributes. As I mentioned, we have two other accelerators enabling self-service, including data science. At this time, I'd like to go ahead and hand it over to Jennifer, who's going to take you through how we've operationalized data science to further enhance our capabilities.
I think you might be on mute, Jennifer.
Sorry about that. Thanks, Katie. Now I'm going to talk through how we are operationalizing data science at Prologis. So first off, what is data science? Most of you are probably already familiar with this, but it's the science of using scientific methods, algorithms, and models to extract knowledge and insights from data. Why is this important in business? It improves decision-making, helps identify opportunities, improves customer service, helps with price optimization, and helps identify trends. True business value is realized when data science projects are operationalized. Operationalizing data science means that models in a prototype stage are deployed to production in a scalable, repeatable fashion, making them usable across the business. This is usually not a primary focus of data scientists, as projects are usually built for a single purpose where scalability and repeatability can be an afterthought. So what does operationalizing data science look like? Here's a view of our current architecture that consists of Denodo, our virtual layer, the source systems at the bottom of the diagram, our data science toolkit in orange, and the data access layers to the right. We will be walking through each of these components in more detail. I mentioned that true business value is realized once a data science project is operationalized. That is due to the following benefits: increased accessibility, efficiency, reliability, and accuracy, having a flexible, repeatable, scalable design, accelerated time to production, and flexible data consumption. Let's take a look at how our approach has increased accessibility, efficiency, reliability, and accuracy. It's commonly stated that data scientists spend about 80% of their time on data preparation. This also happens to be the least valuable use of their core competencies. Using Denodo as our virtual layer drastically reduces the amount of time data scientists spend on this step. Denodo provides centralized curated data as the single source of truth. Earlier, Katie reviewed the building blocks of analytics. Now here are some of the benefits. Centralized access means there's no time wasted getting data scientists access to several different source systems. Cataloged metadata makes it easy for data scientists to find the data they need. Access to data curated by the analysts closest to the business means there's little to no time spent cleansing the data. And data is certified by subject matter experts, which gives data scientists confidence in its accuracy. In addition to the benefits Denodo provides, we have also set up a shared development environment that allows data scientists to quickly access this curated data without the need to configure an environment locally. We use Jupyter Hub for this development environment, where users can work in either Python or R notebooks. This environment is already configured with all of the library packages needed, in addition to the connection to Denodo. Because this environment is managed by us, we are also ensuring environment consistency between development and production, which is important for ease of migration. This development environment ensures environment operating system and library package versioning align, so code does not break when migrated to production. It also allows us to centrally manage library packages. It means that we are only maintaining a single environment, and it enables sharing templates across users. It also comes with the configured connection to Denodo and other cloud resources within our network. This means data scientists do not need to do any initial setup to get started on the development of their data science project. Now we'll walk through how we've created this flexible, repeatable, scalable design. Our architecture involves exposing any data science project as an API. This creates a flexible, repeatable pattern because data scientists can work in the language of their choice and have flexibility in how they design their solution. It can accommodate any algorithm, function, or model written in Python or R. Data scientists can connect to live data from day one. New capabilities are easier to support and maintain. The pattern is easily replicated between development and production environments. And serverless compute in the cloud allows for scaling the functions up or down as needed. Here's a deeper look into the data science toolkit and how it works. The function code is developed in a Jupyter notebook in either Python or R. This notebook is then exposed as an API through the Jupyter kernel gateway. In Denodo, we create a base view that is sourced by this data science API. This base view can be joined to another Denodo view that contains the model or function input data that will be passed into the HTTP request body. The results of the function are passed back to Denodo in the API response and are accessible in a derived view. Now the results of the function are accessible by a simple SQL query to the view and available for use by all of our data access layers. You'll notice the process remains the same in production. We simply swap out the Jupyter components with AWS API Gateway and Lambda. In addition to that, we are using CI/CD pipelines for deploying all of our AWS resources. This has several benefits, including reusability of templates, removing manual errors, enabling fast iterations, ease of rolling back changes, disaster recovery, and it's quick and easy to stand up new environments. We use pipelines to manage our Denodo infrastructure, the infrastructure of our analytics servers, and our data science function deployments. This diagram shows how our Denodo infrastructure is deployed through CI/CD. The source code and Terraform templates are stored in a Git repository. All of the Denodo configuration is done in the user data script that runs on startup of the server. When a change is pushed, this prompts a pipeline build, validation and planning, and after admin approval, the resources are deployed to the cloud. The infrastructure includes an auto-scaling group, an elastic load balancer, and the desired number of instances for the environment. The base install of Denodo is included on the virtual image that the servers use at launch. And all metadata is backed up regularly and stored in S3. This process stands up a new environment in less than 10 minutes, which is extremely important when considering disaster recovery scenarios. Also, having a load balancer allows us to apply product updates with little to no user interruption. We also use CI/CD to manage the infrastructure of our analytics servers and deploy our data science functions. Similar to the Denodo pipeline, the code is stored in Git and the server configuration is done in the user data script. The pipeline steps are triggered on code change and the resources are deployed to the cloud. With this infrastructure, we're deploying an elastic load balancer and the desired number of instances for that environment. The analytic environments that we have currently are Jupyter Hub, RStudio Server Pro, and RShiny. As previously mentioned, we use Jupyter Hub for our development environment. We also use RStudio Server Pro for data analysis where users prefer the advantages provided by the point-and-click UI. RShiny is used for a lease pricing model application. Our data science functions are deployed to AWS in a similar fashion. The function source code, function dependencies, and the Terraform template are stored in Git. The pipeline packages the function code in addition to the steps previously mentioned, and upon admin approval, the API gateway and Lambda function are deployed to AWS. Another benefit to operationalizing data science is the accelerated time to production. As I've described in previous slides, our current architecture eliminates many of the hurdles in operationalization. meaning that we are able to get new data science projects into production faster. The reason for this is there is less time spent on getting access to data, finding the right data, cleansing the data, spent getting ready for development, moving the model between environments, and deploying the project to AWS. And there is no time spent on setting up local environments or conforming to rigid development guidelines. The last benefit we'll look at is flexible data consumption. The final and most important step is making sure that the results of a data science project are accessible to the business. With our design, we are ensuring that all results are accessible in Denodo so that they can be used by any data consumer. Denodo offers multiple options for interfacing with the data. This flexibility allows you to consume the results in the application of your choosing. Some examples of these applications are Tableau, Excel, Python or R, Power BI, etc. Now let's take a look at the various ways we are able to take advantage of the flexibility of Denodo's access layers. Here are a couple of examples of reports in different applications that are currently in use by the business. On the left, we have the procurement should bid Excel report. The construction managers use the report to look at the predicted cost for a new building, broken down by cost categories such as concrete, steel, and roofing. This model helps them make better decisions based on historical data, making recommendations on future cost. The Excel report uses a live OData connection to access the should bid model predictions in Denodo. As reviewed in previous diagrams, the should bid model code is deployed in AWS Lambda. When the Denodo view is queried, an API call is made where model inputs, in this case the characteristics of the building, are passed in the request body and the predicted costs are returned in the response. In addition to reporting on existing buildings, the report features a simulation tool that allows users to input values for a theoretical building and get predicted costs. This is a great example of how we can use Excel to access live results of a predictive model. On the right, we have the Valuations forecasting report in Tableau. This report is used by the Valuations team to simulate what-if scenarios by passing in property values and receiving calculated financial metrics. This is an example where we are able to utilize the function API architecture for a complex calculation that is not easily done in SQL. The Tableau report queries Denodo by passing in user input. This query triggers an API call to the financial metric APIs in Lambda. This makes it easy for non-technical users that are not familiar with SQL to use the results of these complex calculations directly in the reporting tool they are using. It also provides calculated results in a matter of seconds. Another benefit of Denodo is the ability to embed results in external systems by exposing the data science results as a web service. In this example, we have market lease officers that are already using Salesforce as part of their daily workflow while preparing deals. And they wish to access the results of a lease pricing model in Salesforce versus having to use another tool. The Power Pricing API consists of several R models that take in lease and property data and return a probability of closing at a certain rent price, or a rent price if provided a probability. Again, following our repeatable design, these models are deployed in Lambda. Users in Salesforce trigger an API call made to a Denodo web service, where data is passed from Salesforce to Denodo. From there, the data from Salesforce is joined to data in Denodo and subsequently passed in the API call made to the Power Pricing tool. The results are then returned from the API gateway to Denodo and then to Salesforce. Another use case is getting extremely large data sets, such as 400 million line journal records, in the hands of users. Denodo's capability of caching data into Snowflake allows us to subsequently expose both the large data sets and the curated building block views in a tool called Sigma Computing. Sigma Computing allows users to easily explore very large data sets that wouldn't be usable in other applications in the spreadsheet-like UI they are familiar with. Non-technical users can take advantage of these data science capabilities by exploring data in Sigma. It is even easy for those that are not familiar with joins to create their own data sets and collaborate with their team. In addition to the previous examples, we are able to securely share data with external users by using the Snowflake Sharehouse. Similar to the previous example, we cache our curated views from Denodo into Snowflake. We then grant read-only access to the customer's Snowflake account. This particular example shows how we can provide market availability data to partners such as DHL so that they are able to join this to their own data in their own Snowflake instance to determine where there's availability for them to lease for their operations. So to summarize what we've discussed, operationalized data science brings significant value to the business. Using virtualization and having a dedicated data science development environment improves accessibility, efficiency, reliability, and accuracy. Quality data results in a quality model. This flexible design gives data scientists the freedom to develop the solution using the programming language and algorithm of their choice, without rigid guidelines in place for integrating the end result into production. Repeatable, reusable patterns make it easier to support and maintain a wide variety of business capabilities. All of these benefits mean new capabilities are quicker to production, and moving the model processing from the application layer down to the data virtualization layer allows us to reuse the results of the model or function in all of our data consumption capabilities. And that wraps up everything we have to discuss. Thank you.
Awesome. Thank you so much. I know I have a bunch of questions to follow up on that, and we've already got some audience questions coming in, so that's great. So if anybody in the audience has questions, feel free to use that Q&A button down at the bottom of your screen and go ahead and ask them and we can get to them. The first topic I want to cover and the first question that I have for both of you is, after kind of looking through this, I've seen a lot of different architectures for different companies to support exactly what you're doing. And it looks like a fairly advanced architecture. Like, I've not seen a lot of people who have all of these things connected together. I've seen people who are still working on the cloud migration component, configuring that, understanding what tools are available. I've seen people still struggle with the catalog side, with the data virtualization layer. Are there any specific challenges that you and your team are still facing and trying to improve this architecture to address that?
I think exactly what you said. We do have a lot of different tools. We have a lot of different options for users to utilize this data that's coming out of the data lake and out of Denodo and stuff. And so just making sure that we can optimize performance no matter which tool it is. I think that's still something that we have some work to do. And you take a look at it from this way and it's working great, and then all of a sudden you take a look at it this way and you're like, oh, that breaks it, or it just kind of degrades the performance just a little bit. So I think that's one thing. And then I think the data, obviously data is going to continue to be complex, and it's going to continue to take time to curate and define and ensure that we are providing quality data out to various business users so that they can come in and grab it and stuff. And so that is always going to continue to be a challenge of moving as fast as the business does of, hey, we want this, hey, we added this, can we get this added in, and stuff. And so balancing all of that is going to continue to be a challenge for us that we're going to have to tackle.
Yeah, that makes sense. Jennifer, did you have anything to add to maybe some of the challenges you've seen with the current architecture?
Yeah, so I would agree with Katie. I think that educating users on how to use Denodo, even though they're still using SQL to query these views, understanding how that's delegated to the various source systems, how to optimize joins, things like that, to improve performance, that's all rather complex. And I think that that takes time to kind of educate them on how to look for those things, how to apply different techniques to really optimize their performance.
Is there any specific tool that your team is using to understand performance of both models that are being created and the kind of latency performance of each one of these models while they're running in production? So you're talking about operationalizing lots of models, which is great, but then there's kind of the management and maintaining those over time. Have you used anything specific to be able to kind of monitor that and kind of run the operations of that?
Sure. So in Denodo, we store quite a bit of metadata that's coming from different places, logs, CloudWatch, things like that, where we're able to understand performance. On top of that, we have several Tableau reports where we're able to look at things like error rates, latency, things like that. And we're able to make sure that all of these Lambda functions and APIs are working, right? And whether we need to scale up the resources on our particular function because now it's running slower or something like that. But yeah, I would say we tried to get all of that metadata into Denodo and then build the reports in Tableau using that.
Yeah, that makes sense. And I assume the easier you make it to deploy and operationalize a model, the more you have and the harder it gets to manage all of that. So it's something I've seen a lot of organizations who are more advanced and far along in this journey. That's kind of the next roadblock that they've been hitting. We do have a question from the audience. So this question is, across all of your self-servicing options, which options seem to be the top 2 to 3 options the user community utilizes most?
I could take that one. I think Tableau is obviously at the top of the list, and that essentially gives them kind of that analytics dashboard report feature that they can share with others. And then I would say the second one is probably a tie between Sigma and Excel. For those of you not familiar with Sigma, I call it fancy Excel. I'm sure they have a much better definition for that, but it really does. It acts and treats the data like you're in Excel. You can write formulas and that sort of thing. And so that provides the advantage of exploring the data for those large data sets. So that's going to be, like journal line, like Jen mentioned, where you have 400 million records. You never want to look at that in Tableau. It's just not going to work. And that's not what Tableau is meant for and stuff. Whereas Sigma, you can aggregate that data, you can drill into it, you can create calculations and formulas within there. And because of that user experience and front end, it's really great for our business users, specifically our accounting and finance users, to be able to dive into the data there.
That's awesome. Thank you for that. I do have a question about the team that supports this. There's a lot of integration points. This does seem like a kind of complex configuration. There's a lot of tools touching each other and making sure that all of those integration points are working properly. Who in your team or at your company basically owns that and maintains that, and how do you support this entire workflow?
Sure. So within data and analytics, we actually have 19 employees. So we have our VP who's over all of data and analytics. And then there's 18 employees that are broken up across 4 different verticals. So there's data visualization, data integrations, data virtualization, and then our data solutions. That's our team that creates the building blocks and does a lot of modeling of the data itself. And so each of those tools align with those teams. So Tableau and Sigma are within the data visualization. Obviously, Denodo and a lot of our data science is within our virtualization team. Informatica, that sort of thing was within our integrations team. So we break it up like that. And then we also have some fantastic vendor partners that we work with that we really treat as an extension of our team. They really are just a bigger data and analytics team. And so we have managed services as well as development resources that help us to implement and maintain, and they work with all these different capability teams and business users and that sort of thing. And they do it all underneath our guidance. So we still stay in touch. We don't just deploy a team over here to go help them with this. It still stays in touch with our team and underneath our guidance to make sure that it's being built the right way and is something that we can continue to support long-term while still providing them value and not ending up in a really long backlog because we just don't have the resources to support it.
Yeah, that makes sense. And Jennifer, I have a question for you on that topic as well. So it sounds like there might be some additional skill sets that maybe you're expecting data scientists to have. Your title is a data science engineer, which is different than a data scientist in some respects. So can you talk about maybe the new roles that you had to create and adapt when you built out this more advanced architecture? In addition to maybe some skills that you would add on top of the typical skills you see for data scientists, for example, like being able to work with Git.
Sure. So as the data science engineer, I kind of maintain this architecture and I work with the data scientists on what are the guidelines, what are the standards for getting their project into production and how does it fit into this architecture. I would say the data scientists really I wouldn't say their role has changed. They're able to work in R Python and build their solution. The only thing that we require of them is really being able to accept the model inputs as JSON and return JSON results. And so I help them with that if they're not familiar with APIs and things like that. But as far as taking their code and putting that into production, that's something that falls on me. So they're not having to understand Git or how Lambda works, right? Or any of those integrations. That's something that I manage.
Yeah, that's really interesting. I've seen a lot of companies struggle over that kind of division of responsibility between different team members on, are we going to expect our data scientists to know best practices on developing code, for example? So yeah, I find that really interesting. You mentioned that you made the jump to cloud. When did that happen, and what were some of the challenges that made your team consider that, and what was difficult about that journey?
Yeah, so I don't know that jumping to the cloud was the specific pieces of it. When you broke it down, actually worked pretty well. So we took it step by step. So we implemented Snowflake, we implemented Denodo. We're in the process of moving Informatica Power Center to Informatica Cloud. So whenever you start to take it kind of piece by piece and not try to do this big bang, and all of it all at once, that really lessens your risks and also lessens the challenges that you have along with it. So while it's been an evolution over the last couple of years, stuff like that, we were able to start getting value out of it within the first 6 months, using Denodo and Tableau and Snowflake. Within the first 6 months, we could start providing value. We were able to connect some of our more traditional like data warehouse and things like that, move our current reporting platform over to the cloud. So that way things are still going on while in the background we're switching things out, and just taking it step by step has really helped to lessen the risks.
Yeah, have you had to, and that's really interesting because I've actually heard this as a common trend, is that a lot of companies are using virtualization technology in order to make that transition, primarily because you start to have data in different sources at that point. So if you were all on-prem at one point and you start using Snowflake, now you've got two different locations that your data's sitting in, and you got to be able to join that and do that efficiently. So I do find that to be really interesting, that's a trend that a lot of people are picking up on. Going back to the data virtualization piece, I did see that you kind of mapped the results of the models back in to kind of be exposed for other people to use. Have you seen like code block or model reusability? Like, are there certain features that are generated that are exposed through Denodo that are useful for other data scientists, or the results of models, for example? Have you seen like an increase in kind of reusability of that?
Yeah, absolutely. So, for example, the should bid model, like I said, they have an Excel report currently, but even within that report, they're not only using the predictive model for existing properties, they're also able to use that API directly by passing in whatever value they enter, right? So there's kind of dual functionality within just that one report. They're also, they also have a Tableau report that they're able to use. And that's just one example. Because those results are in Denodo, you could have users using them for ad hoc analysis, whether they're working directly in SQL, or if they're pulling that into a notebook for further analysis. And really, we can use those same results across multiple teams, across multiple applications. And that's kind of the benefit that Denodo provides us.
I'm curious too, it sounds like there's a decent amount of work on kind of exposing, you mentioned this kind of certified, uncertified concept, and also exposing and capturing metadata. What has this done in terms of getting adoption from your business stakeholders on their trust of the work that you're doing?
Sure. So with all that metadata, a user, whether they're directly in Denodo, maybe they're a little bit more SQL advanced and they're in Denodo, or they can use that same metadata that we're putting into Denodo, we're putting that into data.world, which is our data catalog tool. This allows them to seamlessly go back and forth. So they're looking at a data set, they're looking at a dashboard, they're using a starter pack to create their own dashboard, and they're drag and drop, wait a minute, what exactly is that metric? Or they think they're using a metric and they're like, wait a minute, I was expecting this number, why am I seeing that number? They can look at the definition of that. And so the definition will help describe to them, how is that calculated, where you provide business details as well as technical details that go along with it. So that way there's really no question about what is there. It's not a guessing game of like, oh, I think this is the right value that I'm looking for. They can really confirm and understand, and they can also see who the owner of that metric is. While we help build and maintain all these building blocks and things like that, when you talk about certain attributes or certain metrics, those are owned by somebody in the business. Now, if they have more questions, they can see who owns that, and they're not going desk to desk and trying to figure that out. They can go directly to them, or even to our own data solutions team and say, hey, wait a minute, I'm still confused, help me out here, and stuff. But our metadata that we're adding in is full of information. The source of it, business logic, technical logic, everything is within there that you can see.
I imagine that takes a decent amount of discipline from your team as well on making sure that that's accurate, up to date, high quality. What measures do you put in place? I know you said you had a Scrum background, so this is kind of targeted towards you, but what measures do you put in place to ensure that that is happening continuously?
Sure. So I'm actually going to go back to our data virtualization team, where they have very strict standards and guidelines in place that we're not going to push an updated view, a new view, or anything like that out into the production environment available to other users without it having that information. That is critical information, not only for us to be able to continue to support and maintain this, but for our end users as well.
Yeah, it sounds like there's a whole set of quality controls around that too, because there are good definitions and poorly written definitions. And yeah,
Absolutely. Yeah, and we also have a whole testing suite in place too. So we use a tool called Tosca from Tricentis, where we can establish these quality tests. So that way we can run them consistently and get alerted if there's any type of issue that we need to get resolved too.
Yeah, I was really impressed by the CI/CD pipeline too. I mean, that's also pretty, an advanced architecture to put in place. I think a lot of organizations are still doing this semi-manually. And so just to see that kind of testing suite and CI/CD in place is really neat. So given the fact that you are essentially creating a ton of efficiencies in this entire workflow, how are you managing the scale based off of user and business needs?
I would say because all of these things are highly repeatable and we're able to, with our CI/CD, we can basically clone everything from an existing pipeline. It's super easy to scale these things. We kind of customize it from there, but we have all these templates at our disposal that we're able to copy. We're able to make very minor changes. But that's kind of the theme of all this and how we try to think about our architecture is making sure that we can accommodate all of these different use cases, being able to scale quickly, being able to accommodate a wide variety of capabilities without a ton of effort upfront, in designing custom solutions for each project, so I would say this enables us to scale very easily.
And it sounds like there's a really well-defined ownership model on top of that as well, because you start to see when these things get adopted in large companies, they have these little rogue teams that are kind of doing their own thing, and they've got their own architecture set up, and they've got their own way of testing. And so it sounds like your team has done a really good job standardizing on that and communicating that and kind of centralizing that a little bit. We had another audience question that says, how long does it take to build this kind of infrastructure, and where did you spend most of your time?
Yeah, I'll go back to what I mentioned a little bit ago about how, this really has been an evolution over the last couple of years, and we continue to, it's hard to say, oh, it took 9 months, because it's been an evolution over time, and it's still evolving. We didn't even have Sigma 6 months ago. So as we add in new tools and new capabilities, like Jen mentioned, it continues to evolve, but we were able to get that initial value within the first 6 months, just by, utilizing the data virtualization and the capabilities that Denodo allowed us to do by joining to multiple data sources that masked it from the end users of where it was actually coming from, if it was in the cloud or on-prem, and stuff. That was a huge advantage to us.
That's awesome. Yeah, that's actually quite quick. And so that's incredible. I have one last question for you. So when you were going through this whole consideration of the architecture and what tools you were using, what was your process of evaluating the pain points, evaluating vendors, and getting the right tools in place? Because that seems to be a huge challenge for a lot of organizations, is understanding, are we really addressing the pain points we're trying to solve here with this vendor? Because technology can't really solve everything. So what was your general process of going through that vetting?
I think a lot of it had to do with obviously being able to be in the cloud. The ability to scale it out and the ability to maintain it. Nobody wants to bring in a tool that is going to be incredibly cumbersome and labor intensive to be able to maintain going forward, and things like that. And then we also look at, what are the capabilities that they have. Sigma is actually a really good example. Where when we first talked to them, we actually said no. You don't connect to Denodo. They specifically connect to Snowflake. That is their sweet spot, and that's great. But we actually looked at them and we said, you know what, hey, you don't connect to Denodo. That's our data virtualization tool. That's where we're pushing the business logic so that we can reuse it across many different applications, choose your own tool type thing. And so by not allowing a tool to connect to that, it really limited our scope of it. Fast forward down the road 6 months or so, we now have the capability, thanks to Jen and the rest of the data virtualization team, to pin these data virtualization data sets into Snowflake. And so now we can now take a tool like Sigma and connect it to Snowflake, but we're still using all the logic that was built in Denodo. We're not replicating that logic in two different places. It's still the same data sets, the same building blocks and everything else that are in Denodo, just pinned down into Snowflake. And now that tool actually made sense because now business users can explore that data, the large volumes of data sets, use it like an accounting user would, like Excel, while still keeping to our core of let's put the business logic in one place and allow the reusability by various tools.
Yeah, that's awesome. That was a really good explanation. So thanks for going through that. I know we're hitting the top of the hour, so I want to thank both of you for being here and sharing this information with everyone. This was really, really cool to see. So I really appreciate you taking the time to put it together and be with us and answer all of these questions. I do want to, real quick, before everybody jumps off, we do have a follow-up webinar on Thursday, like I mentioned. So this one is kind of the more technical deep dive, but we're going to be talking specifically about the COVID-19 impact. So if you are interested in sticking around and understanding some of those concepts, feel free to join us on Thursday, and we'll be sending out a link to this recording to everybody who has registered as well. So feel free to share that with all of your friends and colleagues. And with that, everyone have a fantastic rest of your Tuesday. And thank you again to both of our awesome speakers.
Thank you very much.
Thank you, everybody. Thanks for having us.